Okay, our last video solved systems of equations using substitution. This is our second method. It's called solving systems of equations using elimination. Some people call this Gaussian elimination. They named that after a guy named Carl Gauss. So Gaussian elimination. Back a long time ago, he was kind of a big deal. Elimination. There we go. They're all kind of neat stories with that guy. But basically, it's elimination. And like the name sounds, we're going to eliminate one of the variables so that we could solve for the other one. So let's consider this system. So we have negative x plus 2y equals negative 1. And then we have 2x plus 2y equals 8. Okay, so we want to solve this. Theoretically, we could do substitution, but sometimes substitution actually takes longer. So what we're going to do, so the idea is we're gonna play with these equations. We're gonna multiply them by something. We're gonna add or subtract them. We're trying to get one of the variables to go away, and we kind of have free reign on this. So in this one, if we look at the first one, so we have a negative x right there. So what we're going to do is we see in here, okay, well we have a 2x, and here we have a 2y, here we have a 2y. So these two y's are already the same, right? So what we could do, the idea is to try to get the coefficients of one of the variables to be the same thing. In this case, our y already has a 2 both times. So what we're going to do is we're going to take this whole entire equation. Actually, it doesn't even matter which one you do. Let's do the top one. Let's take this whole equation and let's multiply that whole thing by a negative 1. So what we get then is we have negative 1 times negative x gives us a positive x. We get a negative 2y. And this negative 1 on the right side turns positive, right? Because this negative 1, we're multiplying both sides. Like we're multiplying everything. That way it still stays in balance. You imagine this like a balance beam. Right? If we multiply a negative 1 on this side, we have to multiply it on this side too. Otherwise, one side gets heavier than the other and it goes down and bad things happen. So we did that then. We have a positive x now minus 2y equals 1. We're going to take this one, we're going to rewrite it. So this is 2x plus 2y equals 8. So now you notice that with the top one is a negative 2y, this is a positive 2y. If we add these two equations together, so like just add the whole thing, we're going to add up everything. So x plus 2x, that gives us 3x. Negative 2y plus positive 2y gives us a 0y, right? But a 0 is just a 0. Doesn't matter what you multiply it with, so this just kind of cancels out. Then we have 8 plus 1, that gives us 9. So now if we look at it, we have 3x equals 9. So all we have to do then is we divide by 3 on both sides, and our x equals 3. That's solved. Like our x actually equals 3. So now what we do is we plug that back into one of the equations, and it doesn't really matter which one you plug it into. You'll give the same result, so you're going to plug it into the easiest one. So let me make a note. Plug in to easiest. But you're plugging into the original, not anything that we multiplied. So like this first one, remember we multiplied it by a negative 1. When we plug this x in, we're going to plug it into what the original equation was. So the original equation was negative x plus 2y equals negative 1. So we're going to plug this 3 in. So we get negative 3 plus 2y equals negative 1. And now we're going to solve. So we're going to add our 3. Notice the 3 went negative because the negative out front of the x. Okay, so we're going to add 3. So we get 2y equals, this is now a positive 2. Then we divide. So divide by 2, and y equals 1. And we're finished. So we have x equals 3, y equals 1. If you plug those back in, it should work. Okay, let's do that again. That was so fast, it's making our heads spin. Let's try this again. Let's do a different color in case that helps. Sometimes colors help you see things better. Let's try it again. Let's do it on our blackboard. Okay, we have x plus 3y equals 7. x plus 3y equals 7. And then we have negative 2x plus y also equals 7. Okay, so we have two choices here. We could multiply by something by this x to make this have the same coefficient, or we could multiply this one by a 3 to have it the same coefficient as the top. It doesn't really matter which one you do. You could pick either one. So just for fun, let's multiply. Let's multiply by the first one. So this x has an understood 1. This has a negative 2. So we're going to multiply the whole top one by a negative 2. So this whole thing gets multiplied by a negative 2 so that they match. So now we have negative 2 times x. And then we have a 3, but we have negative 2 times 3, so that gives us negative 6. And then we can't forget on our right-hand side. So we started out with a 7, but we multiply it by times negative 2, so this is a negative 14. Okay, we're halfway there. We're going to rewrite the other one that we had before. So this is negative 2x plus y equals 7. Okay, so now notice we have a negative 2x and a negative 2x. So since this is the case, what we're going to do is we're going to subtract one from the other. Or if we'd been smart about it, we could have just multiplied by a positive 2 instead of a negative, but it doesn't matter. You could think of this either way. This is good practice. If we subtract this one, let me do this in green. We're going to subtract, but we're subtracting the whole thing. So that's a minus 2. So this is negative 2x minus a minus 2. Well, minus a minus is just a plus. So negative 2x plus 2, that's 0x. And we have negative 6y minus y, that's minus 7y, equals negative 14 minus 7, that's negative 21. Okay, 0 times anything is just a 0, so that goes away. Now we have negative 7y equals negative 21. Let's divide both sides by negative 7. And we get y equals positive 3. Da-da-da! Okay, we're almost there. All that we have left is we just need to plug that into an original one. Let's plug it into the first one because that's the simplest. So the simplest is x plus 3y equals 7. We know our y, so we're looking for our x. So we have x plus 3 times, and this is what we're plugging in here. Let me put it in white so you can see where you got it. So this is a 3. And I'm going to draw a line way up there. Okay, we plug that in. Equals 7. So 3 times 3 is 9. So we have x plus 9 equals positive 7. So now we just solve the normal way. So we're going to subtract our 9, minus 9 on both sides, and we get x equals negative 2. So our answer then is x equals negative 2, y equals 3. That point, negative 2, 3, is where these two lines would cross. Ta-da! X goes there. This is your y coordinate, and that's your solution. So that's elimination. We're going to do some practice on that. But basically what you're doing is you're multiplying by something, then you're adding or subtracting these equations from each other so that you could get rid of one of the variables and you could solve for the other one. Then once you have that, you plug it back in and you're done. Okay, see you in class.